Binomials. Bi, of course, the prefix meaning two. Nomial, very loosely translated, means terms. So we're talking about products of things with two terms. The classic question, something like that, x plus 1. So many methods have been seen over the years. There's the FOIL method, maybe you've seen that, first outside, inside last. Face method. Anyone know the face method? Let me show you the face method. The face method is essentially the FOIL method, but you draw the lines in. So when you go first, I go, I'm going to do x times x. It's x squared. Outside, I'm going to do x times 1. It's x. Inside, 6 times x. 6x. Let's do the last one, 6 times 1. I've got a picture of a face, so I know I'm right. See the face? See, there's the chin, that's the smile. That parenthesis becomes an ear. There's an ear, the two inside ones and the nose. And then you got the eyebrows down there. It's the face method. And then we add the like terms and we get x squared plus 7x plus 6. And quite possibly you're at the stage now where you can go straight to that answer. You don't necessarily do that. That's sort of in your head, the x and the 6x. But remember, if you find yourself making mistakes, put more lines in. As soon as you start neglecting lines, if you find a mistake happening, then that's when you go, okay, I'm trying to do too much. Just bring it back. Do more steps. Break it down. Okay, we have our perfect square. We don't want to bother expanding this out every time. A pattern, remember I was talking about patterns, we can predict what's going to happen. A plus B all squared, we can predict what the answer is. We've seen it so many times. We know it's going to be A squared plus twice the product of the numbers plus B squared. That pattern will always happen. We use it to our advantage. A minus B all squared, same deal, but the middle term's now negative. Now in general, I don't know if you realise this or not, when you square, if you've got more than two terms, that pattern still exists. So if I had A plus B plus C plus, and I could keep going as many as I like, and I wanted to square it, I'd get A squared, B squared, C squared, all of those terms squared. Then I'd get twice every possible combination of whatever pronumerals I have. So the A would be times the B, the A would be times the C, A would be times whatever pronumerals I've got in there. Then the B would be times the C, and the B would be times all the other pronumerals in there. Every possible combination would be there. Okay, so that pattern stays consistent. And the difference of two squares. So, what the heck, let's do x plus 2 all squared. Again, I'm not suggesting you would write this line down. X squared plus 2, twice the product, plus 2 squared. And if you're really unsure, you'd be saying, hang on, it was A plus B all squared. So it's A squared, well, A is x, so it's x squared. It was 2AB, so it's going to be 2 times x times 2, and B squared, that'll be 2 squared. Tidy it up, there's my answer. But again, most of us, if not all of us, would be going straight to the x squared plus 4x plus 4. So 3x minus 4 squared, in reality, we'd just be going, okay, there's my answer. Difference of two squares. Doesn't matter whether the minus is in the first one or the second one. If one's minus, one's plus. First one squared minus the second one squared. It's a pattern we know. Hang on, there's 3 in the second one. We haven't got a rule for that. It just means everything has to be times everything. Draw the lines if you want to make sure. So, okay, I know there's 2 terms. I'm going to multiply it by 3 terms, so I should end up with 6 terms. It's a way of keeping check that I've expanded it out completely. So the A, I'll multiply by A squared, get A cubed, multiply by 3, right, there's the A. Now I'll multiply everything by 2. Brilliant. And now I'll tidy it up. Voila, there's my answer. There is another way of doing these longer ones. I don't know if anyone's seen that. You ever heard of this method? The method of detached coefficients. It's a method I found in an old textbook, and when I say old, it was first published in 1880, 70, somewhere around there. Okay, maths doesn't change. Right? X plus X has always been 2X, and it's never going to be anything different. And this was a technique in the textbook which wasn't too bad, a way of setting out the working out. So the first thing they did, so I've got 3 and first one, I'll list all the coefficients. So we detach the coefficients. List all the coefficients of the first factor, starting with the highest power. You'll notice I've got a naught there, because there's no x, so you need one for every possible power going down to the constant. So in this case, I've got naught for the coefficient of x. Then, I'll list all the second one as well. Here we go. By the way, you'll notice when I listed it, I didn't put the 3 under the -4. It's not like it's a negative squared. I start with whatever the highest one is and go down. Now, we multiply all of the first row by the first number in the second row. In effect, it's exactly what I just did. I'm saying I'm going to multiply everything by this number. So I'm going to multiply everything by 3. I'll get 6, -12, 0, -15. Now I'm going to multiply everything by 4, but I will start in the second position. So it'll be 8, -16, 0, -20. Now I'll multiply everything by -2, but I will start in the third position. So basically I start under the number I'm multiplying by in the second row. And then we simply add down the columns, and there's my answer, starting with the highest power. Now the highest power here, if I'm multiplying a cubic with a quadratic, then the highest power has to be, what? 5, yeah, x cubed times x squared. So, bingo, highest power equals the highest power times the highest power. So our answer, there it is, 6x to the 5 minus 4x4, and so on. There's the example that we just did. Doing it that way, writing it down, everything times 1, everything times 2, add them together, bingo, that's the answer we got before. Doesn't matter, see I've got x and y's, it's the coefficients that are important. So, writing it down, everything times 2, or everything times 0, bingo. Now when you put the terms back in, you start with the highest power, the x's now go down by 1 and the y's go up by 1 to work out what the algebra goes in.